Okay, we're going to show how we can use what you might call classic, if that really makes sense, Python techniques to address this question and analyze the data set. The notebooks that I've saved are in this folder here. We're going to be looking at this Google Colab right here. Let's pull it up, and I will quickly run you through what it contains. The first step is to go take a look at the data. So I'm going to open up this link here, and we're going to leave Colab. We're now going to come to this website, which has the data set that we're going to analyze. We are going to use the data in Oxford, and I just want you to have a visualization of what that is. It's weather data from the Oxford station, begins in 1853. The file itself has some metadata descriptions at the top, so in order to read that in, we'll need to strip that out. In addition, it has some non-numeric characters that'll need to be also stripped out. So here we are. We're going to come back over, I will load up the notebook. This will take a few minutes, so I'm going to fast forward through that. Now that the libraries for the notebook have loaded, I will walk you through what's in this notebook quickly, so I won't bore you. Here, what we're doing is we are just setting some styles and color tones and colors for the graphs that we will be presenting in this notebook. Make sure I've done that. Okay. Okay, now first thing is that we're going to read our data. We took a look at it, so we're going to use the request library, and we have now just read in our data. As you can see, it's exactly what we saw on the website over here. What we now need to do, because this is one long string, is convert this into a data frame. So I've built a function here that is specific to that data set. It understands where the data starts by looking at this row, and then collects the information, cleans out some of the non-numeric characters, and puts it in a data frame. So we will do that here. All right, our first step is to explore the data. First thing we're going to do is add a column for date and month, combining these two columns, just easier to work with. And then we'll just quickly run some plots. So what we have here are actually just a plot of the data. As you can see by looking at this, it's not easy to pick up a trend from this particular data set. So we need to do something to be able to better visualize whatever trends exist in this data set. The first thing we're going to look at here is plotting the averages by month. And so 7 here refers to July. This is August. So this, you've probably seen these weather charts before, but these are just the average maximum temperature by month, minimum temperature, days of frost, and rain. And of course, there's no frost in the summer, so that's why this is 0. Now, to make this a little bit more useful, I decided to group the periods into what I've called eras and assigned each year an era according to this categorization here. So prior to 1870, any data point falling into that era would be called early industry, and post 2010, so any data falling into the years after 2010 we'll just label as big data. So allow us to group the data in a way to more easily see if there are trends. So we need to write a function to assign that. We have just assigned that, so now the data set we've added some columns. Now we'll take a look at some graphs. To do that, I've decided to use box plots. Here's the documentation from the Seaborn website. These boxes show the quartiles of the distribution, and the whiskers extend to show the rest of the distribution, except for points that are determined to be outliers. So we wrote a function to draw these, and if we run it, we'll run it here. We will draw those for 4 key variables, which are given here: the maximum temperature, the minimum temperature, the rain, and the days of frost. As you can see, we're focused on temperature. These boxes refer to the eras, so the far one on the right are big data years, anything after 2010. On the far left, early industry, anything before 1870, and then various eras. Just an arbitrary grouping, but it does allow us to better see what is happening. As you can see, it's still hard to pick up a trend, although probably there is some increasing in the maximum temperature. If we then filter these and look at just 1 month over the entire period and see the trend there, it's a little more visible. So in this case, selected January. So these are the maximum temperatures for January over the entire period. The minimum temperature, same variables, the rain and the days of frost. And then down here, we've done the same thing for July. So now we're in this box plot, we're just looking at the July observations over the entire sample or data set. And now we can very distinctly see an upward trend. You can see these last 3 errors look like there's absolutely an increasing line. We also see it in the minimum temperatures over here. Okay, so now what we want to do is determine if that trend is statistically significant. The first thing that we decided to do here is take a look at the distributions of the data set. And in doing so, we get the plots that are down here. It seems to have a bimodal component. There's 2 peaks here. What this means is that we need to be careful with some of our statistical tests because many of them assume some sort of distribution, most commonly a normal distribution. We can then dive a little bit deeper to see if we have a normal distribution here and if we can use that to do a statistical test. As you can see, these are the QQ plots. These are this is a test for whether a distribution or a sample data set follows a particular distribution. The straight line is the distribution. The curved line here, the plotted line, is the actual points. If they sit on top of each other, then it's a good sign that the sample that you've drawn comes from that distribution. If they don't sit on top of each other, then it may not be normal. And that's kind of what we're seeing here. If we then, though, say, hey, why don't we just pick a month and look at that month and see what kind of a distribution we have here. And here what we've done is we've done that for July. You can see this looks more normal. And if I come down to the QQ plots for that, okay, this looks a little more reliable and gives us comfort that we can probably use some sort of statistical significance test that relies on a normal distribution assumption. And so to finish this off, that's what we've done down here. We've done a t-test for the averages, just to pick a sample. Here I've picked sample B is anything after 1970. Sample A is between 1870 and 1930. And the question is there a statistical difference in the mean temperatures observed in this data set between sample B and sample A? We run a t-test using the stats library here, and it comes back and says the null hypothesis can be rejected with over 99.9% confidence. So here is the summary of the analysis. The average maximum temperature in July months after 1970 has been 22.7 degrees. The average maximum temperature of July months between 1870 and 1930 was 21.4 degrees, a difference of 1.3 degrees Celsius. And as we said, that difference, based on this data set and adhering to our assumptions, is statistically significant. And so we can reject the null hypothesis with a 99.9% confidence, meaning we can reject the idea that the means are the same in this sample B as they were in sample A. So in conclusion, this analysis did do a nice job of analyzing the data set and addressing our question, can we pick up statistical evidence that temperatures in this area are warming? We also created some nice plots, as you can see here, which did help us tell our story, including these box plots. I will say, though, you can see it's a rather long notebook. There's a fair bit of coding that needed to be done to actually get this out, pull this out of the data set. And so it's a fair bit of work. On the positive side, that work does give us a very good understanding of the data set and what the data set are telling us, because we've done things such as plot it over time, group it into various eras, look at the distributions, and then decided on an approach for our tests, which was to look at the months of July.